Hello. So today we're going to move the render for this project, which is currently it's currently using the Windows renderer, and then we're just using arrays of floats as a stand-in for our vector math in order to do our vector math, and this upsets me greatly for obvious reasons. Very difficult to manipulate these. As you can see right here, I have to manually do the rotation matrix in this way. I don't mind manually putting together a rotation matrix, but manually multiplying the rows by the points in the rotation matrix does make me upset. So basically I want to take all this math you see here, which is driving the line drawing placement of these lines on this asteroid character, on this this little spaceship we have here. I want to move that to a vector library that we have installed, which is obviously GLM. Um, and yeah, I'm just going to record my process of doing that. We're going to dive in probably a little bit into the build settings of this application in order to do this, which will be interesting. But yeah. We may also have to touch on serialization. We'll see how it goes. Okay, so we want to include, let's see, do I have access to GLM yet? Oh, I do. I just straight up do. Perfect. All right. So that was easy. Oh, you know where I actually need it? I don't need it in here. I need it in the player component definition. Specifically through store. Oh, we should also convert this to the new... yeah, we'll also convert that to anything. Okay, so now we're getting into... we're starting to see code gen stuff. How is that going to handle... I don't know how well this CodeGen is going to handle the GLM stuff. So I think my idea right now is we'll just ignore it, and then we'll come back to that later. Or you know what? Why not? Let's just throw it in there, see what happens. I think, from what I remember, this should be fine. We can test it, I guess. Once we move back. Actually, you know what? So we can compile it, we're going to keep the x and y variables here. Variables. Going to build it. So when we do a build action with the way this pipeline works, it's going to kick off this component reflection project, which is under this components, this gen component reflection, and then that's going to output into here. All right, we had an error. Command exit. Okay, so for whatever reason, it looks like our generate reflection program failed, and the CodeGen program is found right here in this thing. This is and the way it works, just for a high-level overview. This is actually, instead of doing something like using Clang or doing any of that other reflection stuff, I actually wrote a very small parser that parses only a very small subset of the C++ language. And that's what we see here, and we use that to extract the information between the CodeGen keywords, and allows us to do stuff with that. Kind of wondering where this broke. Let's think. We'll dig into this a little bit. What is the debug dummy transforms.h. Okay. Does dummy transform even exist anymore? I don't think it does. I think we want to change this from dummy transform to asteroid player. Or asteroid components. Asteroid components.h. Apply, okay. Asteroid components, of course, has the asteroid player in it and the asteroid input state. And so I'll set this as my startup project, give it a run, see what happens. Okay, so it looks like this is where it fails. This token, yeah, I mean, that makes sense. Looks like the data, looks like it's trying to access a null pointer. Where is this supposed to be set? If I remember correctly, this basically means that it couldn't find that pointer in the lookup table? Sorry, in a symbol table, specifically. So yes, if we're a field servant, this is the parser. Yeah, this is the semantic analysis right here. It's this resolve type function, I believe. Right. Okay, here we go. Ah, okay. So just I have to manually define the type here. Fair enough. No. Wait. Right. Okay, because that would make sense. So what's happening right now is that we know it's a user-defined type, but our code gen doesn't end up running over GLM at all, which means that it's trying to look up this vec2 as a user-defined type. However, we haven't parsed it in our code gen, so it obviously this find user-defined type function fails, and that's not good. We should just we should assert here, or maybe in the previous function, to say, hey, user-defined type not found. Potentially you need to manually define it, which is what I'm about to do. I'm going to go manually define it. What would be the best way to do that? Component reflection, that actually generates the code. Type to string. So yeah, that's the code gen. This is the parse tokens. The user-defined type, parser data reset. We want to, before it goes and parses any tokens, so this is the type pass, then this is the field pass. So before it does any of this, like the first thing we want to do in the type pass is we want to add our implicit types, and we can probably at the same time, I would say actually before this we'll do like a manual define pass. That's what we'll call it. Or just a manual defines. Manual definitions. So the user defined type symbols, and then UDT symbol size dot. Shoot, we need a token for that instead of just a string. But we can do that pretty easily. Start index, line number, file ID, end index. I think the problem is it's going to look up. It's going to use these 2 bits of information to look it up. I think the smarter thing here would be to in the identifier, maybe we have a manual, or maybe in the type itself. Maybe we just set this to null pointer, right? So the identifier we set to null pointer, and then on the type we'll put in a second, not token, but no, why did I not put everything at the top of the file? Oh no, it's a token. It's a user-defined type. User-defined type. That's not how you spell defined. User underscore. Here it is, unsigned field count. So we have the token identifier. So if that is null, then we'll have we'll override it with that string name. Otherwise, we prefer token, but if identifier is null, then we will assume that the string name is valid. Name, and so this will be, that's what it'll be. Defined, I think I also, UDT symbol size. I think I need a hash of the name as well. We'll see about that in the future. Field count is 2. Field identifiers. That's rough. We're going to have to do that. Another one of those for that too. We know the field types. Field types? Is this a pointer? Oh no, you can't just only have a certain amount. Field type. What does type.data.id? So this is how we define an F32, which is what this is. So it's dot user defined as false. Data.id is going to be built in type F32. Okay. And then this is true for 1 as well, but we need a field names. Field identifiers, string, field names. Okay. And we'll only ever access field names if we find that the identifier is null as well. Field names 0x. And y, perfect. Okay. And then UDT symbol size was equals 1, obviously. All right, so now we have that. Now let's look at our code gen. There's this token to string function that we're doing, but in my eyes, no, this makes sense doing it this way. Because this is going to be a little tricky. So I basically need to convert every single one of these token to strings to a type to string, I think. Sorry. I want these token to string functions to take into consideration the name override. However, it's gonna be slightly tricky. I think the way to do it is I'm gonna have two functions. I'm gonna have a UDT to string, a user defined type to string, and that'll take care of the identifier, and then we'll have a UDT field, and then we'll manually pass in the index. Where's the token to string function? I think I keep the token to string function around. That shouldn't be a problem. Token to string. All right. So we'll do another one that's UDT ID to string user defined type pointer UDT. And we'll just stub it for now. And then there'll be another one that is UDT field to string user defined type pointer UDT, and then an index. Perfect. Okay, and then this one should be pretty easy. So if UDT identifier is null pointer, or isn't null pointer, then we simply want to return token to string UDT identifier. Easy. Next, if it is though, we just simply return UDT name. Okay, that was relatively painless. I think a very similar thing happens here. So UDT identifier, if that isn't null pointer, then go ahead and do the token to string on UDT field identifiers J. Else return UDT field names J. Oops, not J. Index. Okay, and those are our two functions. Now we're going to go through this. Instead of token to string, UDT to, ID to string. Type to string. Types to string should be fine. The type field should be filled no matter what. UDT field to string. How big is UDT? Do we want to pass that by copy or by pointer? I think from remembering it, we definitely want to pass it by pointer. I could always take a let's do a const reference instead, since const, because changing all that code to pass a reference or to pass a pointer is harder than changing these small functions to use a reference. All right. So back to where I was. UDT to string, type to string, UDT to string, UDT field to string. UDT to string, ID to string. UDT field to string. Type to string. Sure. Token to string. UDT to ID to string. Token to string. UDT field to string. All right, that's it. Let's go ahead and run it. Okay, so field find user identifier, sure, okay. So it's trying to use the name hash to do the comparison. So that's why we need the name hash. Okay, that should be easy enough to fix. And here, name, U32 name hash. Go ahead and hash the name real quick, which is relatively easy. User defined type symbols. I should probably grab a reference to this point in the array instead of doing all this, but we're maybe too deep now. Runtime hash glm vec2. Sorry, not runtime hash, compile time hash. Since that's a constant. And this does this macro does an x65599 hash, and it does this at compile time. So that's really good. All right, find user defined type. First thing we need to check if the user defined type symbols I that identifier is equal to nilpotent. If it is, otherwise, do the old check. If it is, we'll take that user defined type symbols. We'll take the name hash instead of looking up the identifier's hash. All right, try that one. Token to string. Where are we still using token to string? Type to string. T if user defined. Okay, fair enough. We'll add the exception. We'll add the special case here too. T data pointer identifier. This is probably not the best design because now we're adding all these edge cases to all of these different places. So I'm not incredibly happy about that, but this isn't the problem I even set out to fix today. So yeah, I guess we'll think about that in the future. Oh, data.pointer is no pointer. Interesting. Type. The value we're looking up is 3. Okay, there's something weird going on here. Info. The one we're working on right now is glm vec2. It should only have 2 field types. This is garbage, right? Like look at that. Ooh, that's pointing back at itself. Let's see, how am I constructing this? Field count is 2, and there's only 2 fields. And then we plus 1 to the size so it doesn't get overridden by the type pass. Let's go to that error case again. Did I set user defined to true? No. I set those to false, which it should be. Okay. For whatever reason, field count got set to 5 here. So it really should only be 2. Let's investigate that. Okay. So, yeah, field count is 2. This is fine. It's not until here. String length. Yeah. Oh. This is very strange. User defined type symbols I. But I is the index into the stream. Is this... Didn't think so. This is very wrong. Because that is the index into the stream, is it not? This is the token stream, yeah? Yeah, these are tokens. We have 3 symbols, which there should be. There should be 3 symbols. There should be the manually defined one, and then these 2 components. Even though this one doesn't have the codegen markers in it, it still picks up on the fact that it exists. Wow, look at that. So, let's think. This is straight up wrong. Using this I to index into the type is very wrong. So what do we want to do? We want to look up the user-defined type that's associated with this token. There's a couple ways to do that. We could put it on the token itself right here. That would be kind of silly. Is there any other uniquely identifying information about these tokens? Potentially, we could use that instead of the token pointer itself. Well, actually, oh, right. The UDT has a pointer to the token, so we can search the symbol table. Right, let's just do that. This should be very easy. Search the symbol table for U32, I is equal to 0, I is less than UDT symbol size plus I. If UDT symbol size I dot, oh, whoops, UGT symbols. I typed it all the way out. User defined. Oh, but the problem is I can't spell the word defined accurately. Defined type symbols I if that identifier, and in the previous case with the manual definitions, the identifier is null, so this shouldn't be a problem. So if it's t, then current UDT is equal to user-defined type symbols I. Then just grab a pointer to that. Perfect. Okay, that was a really bad bug. I'm glad we caught that. Oof. Right, yes. Field count. Did it not find any? So if the type is the key, oh wait, whoops, not this one. So this is the class keyword. We actually want the next token, so stream I plus 1. Which is, and the next token should be identifier, barring the fact current UDT got nulled again. Barring like any sort of syntax we insert in there for some potential reason later. Okay, stream is 1. This identifier is null, yes. Oh, silly. J, 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 J. All right, that should do it. We should hit that. Perfect. Okay, now our current UDT is valid. We're still hitting this problem. This is one of our actual user-defined types. Okay, so this is the class with it in it. User-defined type to string. Data is null. Data shouldn't be null. Where is data set? Where is the field types type data set? Right, because this field types, and then this is our first field, which is our GLM vec2. Wait a minute, that's not the, we're dealing with the next one. Why? Oh, it skipped one. So this is the data we're looking for. This user-defined false. Oh wait, no, all of these are like that. Why is this pointer different? Whatever. Let's go to here in the type definition, resolve type token ID. Let's see. All right, so the first resolve should come here, find this, and then data pointer. All right, it should be pointing at GLM vec2. Perfect. Return t, build count plus 1. The next thing it should find, statement terminator. Okay, so we found the next field. And this should be What? Keyword class. Oh, that's just the first one. Okay, the identifier. Resolve the type. Current field types. 1. User defined is got set to true. Interesting. That shouldn't have happened. Let's try that again. So this is the second one. Text hash is 78. Then yeah, I can't find anything. Okay. If we're in a class scope and we're a field, and if we find an identifier, right, and this identifier is potentially silly. Don't, again, it's only a subset. Don't try to use fancy features here. That would explain it. User defined false, F32, that's what I expected. User defined false, 32, defined false. Yeah, F32, alright, perfect. Alright, that code gen. So that successfully actually generated the code. Let us see what the output file looks like. You can't do that trick here. Oh well, since it successfully generates, we can just run the actual program, and then we should be able to build it. For succeeded, which means components include for reflection, reflection.age. Fairly certain this is where it's supposed to dump the reflection information. Build, please. Rebuild. Oh, here it is. Get type xy f32 glnvec2. Does that build? That builds. Okay. All right. So perfect. So that looks like it's generating properly now that we're using this position. You should still be building. You are. Okay. Now, what we actually set out to do, which is hopefully, in what places am I using? The angles stay the same, but these x and y's. Let's go look at all the references to these. There shouldn't be very many. Okay, not just generic X. And not that, not that. Why is it, it's just showing me anything with the letter X in it, which is hilariously awful. Like, oh my god. That's, okay, cool. Good to know. Current project, please. Oh boy. Open documents. Let's go with that one. And then we also want the asteroids renderer and the asteroids input. Okay, so here is all the actual definitions of it. So these are all the places. There's not too many, and I have a feeling it's counting every single one of those 3 times, and it is, because it's a lovely program. We're just gonna get rid of this now. Boop, boop, boop. So asteroids input and asteroids renderer. Can get rid of that for now. I think this one's going to be the one with the most change because GLM IVEC2 0.1, 0.2, 0.3. GLM IVEC2 R.1, R.2, R.3. So the R just in this case means that it's been rotated. That's the rotation point. So we know this is the model essentially. Is this first bit is where we're defining the actual triangle and how big it is to be. And so we're going to quickly move that there. Let's see, I don't... GLM rotate. Yeah. Trans. Yeah, I have to get the matrix stuff in here, which I think is include GLM. Nope, not that one. Geometric. Oh, let's see what's in here. GLM rotation? No. GLM rotate. We're gonna look up. Looking up reference matrices. Yes, I understand. I know how rotations work. GLM GTX. Okay. All right. The question is this going to have 2-dimensional ones, or is it just going to be the 4-dimensional ones? That looks like a hard to find 2-dimensional. Let's think. I could keep the rotation matrix manual. It'd be a little less painful. It would, I mean, this would, system would be less painful in general. In that, like, all the definitions and all the translations I can still handle with this. It's just this rotation kind of sucks. Wait a minute. I can write the function to create the rotation matrix. I actually don't mind that at all, because I know how to do that. The question is, can I easily rotate a 2x2 point by a 2x2 matrix? 2x2, call it A, and then so r.1 is equal to A times 0.1. Okay, yeah, looks like GLM likes that. So we're gonna write the GLM mat 2x2 2D rot. Rot 2D, sorry. And then float angle. Sorry, not float, F32 angle. Should be pretty easy. Return. Will it let me do it in that format? Is that okay? Perfect. So it'll be cosine of angle minus sine of angle. Sine of angle, not that sine. Cosine of angle. The rotation is equal to rot 2D player angle. And then we can say very simply r.1 is equal to, well, honestly, 0.1 is equal to, we should be able to do px. Let's ignore this for now. Player position plus rotation let's just inline it to 2D player angle times 0.1. 2, 3, 2, 3, and then I can get rid of all of this. 0.1 x 0.1 dot. Yeah, so this is much better than what we had before. Whoops. Let's, instead of changing those numbers, which could potentially lead to bugs, we're just going to make the minimal changes. So yeah, the what we had before using those float arrays, pretty bad. But now we have this format, which I like much better. And it's about half the code too, so that's nice. Let's quickly, let's see, where is the difference in the math? There is none, okay. Although I doubt that it'll let me do the copy side. I may still have to break this out into X and Y because of this drag stuff. Actually, that should all work because we're going to leave all the physics stuff here. So this is L velocity, obviously, and then this is That's the acceleration due to input. This is the drag. And so all of this physics stuff is already being done in this, and I don't want to rewrite this copy sign function for, I mean, it actually wouldn't be too hard, but point being, I want to test the actual rendering by itself first, because we did go from integers to floats there. Potentially some issues. X is not a member. You are correct. P position 0, 0. Anywhere else? Nope. Ah. Oh. Just use that 0, 0 instead. Oh. Boy. Something's a little wacky. Basically what's happening is the inputs are not quite right. I think we got rotated about somehow. So if I just hold down up on start, oh, if I hold down back on start, that's what it does. Alright, we're on screen. Ooh, as you can see, not good. Not how Asteroids is supposed to work. Alright. Interesting. So the render is a little screwy, it looks like. Should I miss some logic? I don't think so. Rotate it, then translate it. It's scale, rotate, translate, yes? Yes. Alright, so then what's the problem? 0.1, 0.2, 0.3, 0.1. I don't think there's a problem. That upper left point is the point that I expect to be 0, 0, unless I'm fixing that somewhere. No, I'm not. Well, actually, I should be. Oh, that was some logic I missed. This width and height addition. Yeah. Position, let's re-add that. And then there may also be a modification to this angle that I need to make. Let's see. What was, oh, it's probably not my last git commit. Or maybe it is. Let's pull it up. Spoonfy. Where's the git repo? There it is. Git def. So C astro. These. No, the asteroid renderer. Oh no, that's completely new. Darn. Commit often. Let's just fix the bug instead of looking at what I was doing before. So glm ivec 2 screen dim is equal to width height. And so we're just going to add screen dim divided by 2 plus screen dim divided by 2 plus. Why is that not working? Hello? Oh, so that's a straight position. Eh. Eh. Does it not mind being past floats here? 'Cause these are definitely floats now. Oh, it's definitely just gonna, we can just throw around in there. I need to find out how to mute that. I don't have Slack open. Oh well. 2.0f. Let's just say a truncation for now is probably fine. And we'll see how weird it actually looks in a second. Doesn't look that bad at all. Okay, so these are being done. We probably want to add 90 degrees, which is pi over 2, 4.5 divided by 2.f. Ooh, not multiply, thank you very much. Not equal to either. Oh my gosh. I'm not too worried about, yeah, okay, so this is, ooh. The right and left is still inverted, so we're gonna, slapping that with a negative isn't gonna help. It's the wrong direction, so we need to slap this with a negative. Sorry, instead of subtracting the 90, which I don't think, that wouldn't have changed the direction, that would have just translated it. Okay, that looks good. Alright, I think we're back in working order now. Excellent. Okay, so yeah, moved pretty short one today, minus all that reflection nonsense. But yeah, I just wanted to move this to GLM because, as I noted in my previous dev vlog, doing all that math using arrays of floats is annoying. I will eventually get around to potentially translating this, potentially not. I don't. If I need to, if the next time I need to change this code, I'll probably add something. But for now, I think I'm good. All right, I think I'm gonna call it there. Thank you so much for sticking around.